Okay, good afternoon, everybody. Thank you for joining us. My name is 𝗧𝗃𝗚𝗃. I'm the marketing manager for SIGMAXIM. We're a PTC partner, and we specialize in Creo automation solutions. Welcome to our webinar on Sigma MBD, Prepare Today for Tomorrow's MBD Success. If you have any questions during the webinar, please press the Q&A button. It's at the top of your screen, and type in your question, and we'll do our best to get to them at the end of the webinar. Before I introduce our speaker, I'd like to do a very brief introduction on SIGMAXIM. Okay, so SIGMAXIM has been in business since 2001. We're a global company with customers and operations in the US, Europe, and Asia. We're a PTC software and service partner, and because we work exclusively with Creo, we can really maximize the benefits of our solutions versus a CAD agnostic approach, and we have a very good relationship with PTC. We provide Creo automation consulting services as well as develop Creo automation software products. And we're very proud to say that we have over 1 million Creo automation applications running right now worldwide. It's a very great accomplishment. Basically, if it can be done in Creo, it can be automated. So we have 6 boxes here to categorize some of the things we do, the way we look at automation, but we could have 600 boxes there. We just to give you an idea of some of the types of automations we do, some customers have CTO type products and semi-custom products. Some have custom or one-off products. Some of them have very large assemblies. We have something called Virtual Master Model, which is a very innovative solution where nothing is suppressed. We have a webinar that focused exclusively on that topic in case anyone is interested. We automate MBD, which is what we're talking about today, best practices and standards, and all the way to manufacturing. So if it can be done in Creo, we can automate it. That's the main message. Okay, so again, we are automation experts. That's all we do is Creo automation. And our implementations are fast, and they get up and running very quickly to give you an immediate ROI. So it's in days and weeks, not months and years. We use a building block approach to automation. So no matter how large or complex the product is, by using small building blocks, which are smart objects containing all the rules in that part, we're able to just put one block on top of the other and build very large products. And that enables us to have infinite scalability. We can build and automate as big a product as you want, which is a true game changer and something that in previous years was just not possible. Also, very important, we offer worry-free maintenance. One of the things that was always an issue was, oh no, we have a new version of Creo. Are the automations going to work? Well, with us, yes, they will work. As I said, we have a very strong relationship with PTC, so we're able to maintain our platform to ensure it works in every future release of Creo. You can rest assured that it will work. You never have to worry about that. Okay, and I'd like to introduce our speaker today. It's Charles Farah, who is the technical director for SIGMAXIM, who's based at our headquarters in Massachusetts. So over the last 20 years, Charles has successfully delivered numerous implementations for SIGMAXIM clients, ranging from technical configurators to design process automation and manufacturing process streamlining. Previously, he was at PTC. He worked for several years, primarily as a product manager in the CAD/CAM area. And before that, he held several positions in applications engineering, consulting, and business development. So Charles has over 30 years of experience with Creo. So today he's going to talk to you about our new Sigma MBD toolkit. And now I'm going to hand it over to Charles.
Thank you, Maria. And hello, everybody. So let me, before I start, just to look at the agenda, right? So what I wanted to do is just talk about what is MBD and try, we also hear about MBE, so we differentiate in our mind what's MBD, what's MBE for if anybody is new about the topic. I want to talk a little bit about the challenges with implementing MBD and how much effort it takes, and how we got here. So what's our history with MBD, and what have we done so far, and what make us kind of start thinking about how to solve this problem in this way. And after that, I want to introduce the solution that we call Sigma MBD. And so just starting in the basics, what is MBD? Basically, it's documenting your design in 3D without the need for drawings. So that's the simple part of it. And primarily we're using annotation to do that. You see in here. So that's pretty simple, but it's really not that simple for anybody who's tried to get in there, because basically it's when people try to check it, it's actually, it ends up being that MBD, even though it's simple, you don't have the drawing, is actually much more complex than drawings. And for novice, it takes longer to document the drawing in MBD, primarily because it's designed to be machine-to-machine communication. And humans, when you remove that layer of interpretation, which is the drawing, it adds to that complexity. It really requires much more consistency of the data that's going to be generated. And this is a research basically from NSC and Sandia National Laboratory about how long it's taking for novices to get in. However, it is once you get there, there is a lot of advantages. But what makes it more complex? Well, if you really look at ISO alone, there's over 16,000 pages of the standard ANSI. The ASME's got 1,200 pages. But on top of that, every company layers their own standards to ensure that consistency in how to use the data downstream. So once we start looking at this, we end up actually looking at a lot of challenges with training users, with user buy-in, with maybe complain that annotation might be wrong, missing, inconsistent. And when you start losing that consistency of the data, you start losing the advantages of having MBD. And there is plenty of them, but I really start boiling down to consistency. The other stuff is that to get the rest of the ecosystem to be able to use that data. So sometimes you still need drawings. So if you're going to have to do both, what's the advantage? So we want to start solving these challenges one by one. And in order to do that, we start looking at what 𝗵𝗚𝗀 is that the journey, right? So there is an MBD journey that you have to go on. And there is many MBD journey. We'll talk a little bit about that in a second. So when we start talking about the journey, you start seeing things that are, so basically what people call the maturity level, a company maturity level in that MBD, MBE space. And when you start looking at that, you say, now you see it broken into maybe 4, maybe 6 slices and phases, basically, of that maturity level, from drawing-centric all the way to model-based enterprise, right? But, so I broke here in 4. And the way I looked at it is that, okay, every company start where drawing is the master. That's been the tradition for decades, right? Drawing is always the master. 3D model is just a mean to give us a drawing. Now, so it's not controlled. But so in order to start moving a company into MBD, what we want to move them is that the 2D drawing, although it stays the master as a first step, we want to start having the 3D model being verified, the 3D model being controlled and accurate to it. So most companies are either here or here before they transition to, either in level 0, level 1 before they transition to MBD. And then we're moving them to MBD maturity level 2. We consider, okay, now here, the 3D model becomes the master. The drawing, if they doesn't agree with the model is always going to be the master. So the design intent is fully captured in the 3D annotated model, and you're generating a TDP, a technical data package, from these 3D model. And from here, you go to this maturity board where we have a fully rich TDP output fully loaded model with all associated artifact that's coming with them. So we want to move people in that way without losing the throughput, engineering throughput. And so we look at it, though, that there is multiple journeys. So it's not enough to just define the standard and you go in there. The very first thing you're going to find, we have the employees that has to be trained and getting comfortable with how they're using this without losing throughput, without basically by being just as effective. The company is transitioning, the data of the company is transitioning and how you're going to use that data. But also you might have customers and vendor that cannot use this 3D data that way. And you have to give them some drawings or some representation in drawings. So all of these journeys are important for the successful transition in there. So before I continue, I like to look at it about, MBD. What is MBD? What is MBE? We hear about MBD, we hear MBE, model-based definition, model-based enterprise. And us as a company that are specialized for the last 25 years in automating Creo, our expertise is in Creo. So that means when we set out to get on that project, we said, what can we do to help in this area? And what we can do is by looking into, okay, the Creo. So what happened in Creo? So there is a workflow for MBD, and it starts with preparing the data. So the start part, the combination state, all the preparation that has to happen for the data. We enrich the data by annotation primarily, with text, with GD&T, with symbol, with surface finish. And we want to ensure that that stuff doesn't have any errors. So it's consistent, it's accurate. So we validate that data, we verify all the PMI against definitions, rules, and standards. And at the end, we want to publish. And publishing is sending it outside the realm of Creo in that area, in that space. And it could be sometime also that we want to publish to 2D data because some of our suppliers, some of our customers, or maybe legal require us to have some 2D data in order to of that representation. So, and from here on, you have the consumption. Now the consumption is now in the realm of the MBE, the model-based enterprise. So this is kind of outside our scope at the moment. And we are basically looking at this scope to get all the data ready for consumption. So now we start looking at it. Okay, so in order to do that, we want to actually provide tools to help people easily move into MBD without losing throughput. So that's the goal. And we have a history actually working in MBD, us, even though this is a new kind of packaging that's coming up, that came out. So for the last 15, 20 years, we've been helping our client with very large MBD implementation. And usually they have their ideas of what they're trying to do. And we're an automation company providing them the tools to do it easily. So we're implementing on their ideas to ensure consistency, to speed up user adoption, and to simplify these complex tasks as they move into the idea. But over the years, we've also formed our own ideas of how we will transfer people. And we could then come up with a out-of-the-box bunch of a toolbox, basically a tool set out of the box that help people transition without having to go into these very long implementation project where they are developing their own implementation automation themselves. So we call this Sigma MBD. And basically a bunch of tools that we have right now to do this, and most likely there might be more also in the future as we have other ideas where we find that we can help streamline that space. You can find more, and you will see stuff like MBD checker, like the annotate, update, etc. So I will go through them one by one just to describe what they do, and lots of movies basically. So let me start with. I'm going to start with MBD checker. So I'm not going to start systematically how you prepare the data, you enrich it, etc. I want to start at the back end, at the validation. And the reason I want to start there is because what we want to do here is ensure the consistency of any MBD documented part and assembly to be consistent, but at the same time, we also want to facilitate user adoption. So we want to have a learning tool to get people up to speed on their own, understanding what's wrong with it. And usually you have a checker, you have experts that have to look at everything and start finding the issues that happen in there. What we have here is an automatic system that catches and fixes error and gives the user the information about what's wrong with what they've done wrong so they don't keep doing it. So that's the learning part of it that's taking place here. So what does it do? There are lots of checks. There's like hundreds, right? And basically what it's doing is GD&T and GPS and tolerancing checks, checking all other PMI like notes and symbol, the presentation, readability, visibility of those PMI, geometry and all the semantics, and the CAD modeling practices. So basically, let's start with CAD modeling practices, ensuring that it makes sense. It's follow company standards. It's stuff that you probably used to see in model check, for example. So we want to do that, but also other stuff too. Buried features, deleted features, something that is noticing some modeling that don't make any sense. Stranded features is something else that we would check on it. Things that maybe you don't do with model check, but they are actually quite important on the MBD side, like, for example, multiple outline, a surface ID that spans multiple outline, and we happen to be referencing it in some PMI. So that doesn't follow, so we will catch and fix stuff like that. Water, like holes, for example, where in Creo there are the two surfaces, but we want to really reference the full hole, the surfaces of both sides. So things like that. The other stuff we're going to do is look at the presentations, so readability, although MBD is intended to be machine-to-machine communication. Humans still need to be able to see it and make sense of it. So, for example, a annotation where it's flipped, we're going to fix it. A visibility. So here, when you look at it, well, nothing looks to be bad. Machines has no problem reading it, but there is a annotation right in the back, and something like that is very easily missed without automation. So something like that we're going to discover and allow people to go and fix it. So things like that. Another thing is, like, if you look at this, you have an annotation that is at this angle or at that angle, it's readable, but it gets to a certain angle to stop being readable. So readability of these. So we're going to notice these skewed angles that don't make any sense. Then we're going to talk about PMI checks. So PMI checks such as geometric characteristic symbol. Do they make sense? Do we want to check the geometric characteristic symbol versus the semantic references? Do we have any error in there? Does the semantic make sense? The shape symbol versus its semantic references, that makes sense, right? In this case, whether we have proper semantic references for whatever annotation we have in there. The surface tolerancing, do we have any mistolerancing in there? Any surface toleranced, we will notice it and provide some correction tools for it. The semantic reference sizes, do they make sense? Are they in the middle bound? Is the geometry properly defined with what you're defining in the PMI? And the last thing I'm going to talk about here is the non-redundant datum degree of freedom. So we're going to test all your datum to ensure that you have proper, is your part either you have a redundant degree of freedom, or maybe you don't have it properly locked. So you're missing some datums in order to lock it. So we're going to analyze those for your degree of freedom. So let's look at how it works. So the very first thing, so we have this model that's fully documented with combination states. And what we want to do first is, so before we release it, we want to we want to validate to make sure that we don't have any error. So the tool comes in and you have, here's your MBD checker, and you have some configuration you can define. So you have hundreds of these check. Each one of them will tell you what it does. And you have some help, you have some information, and what's the point of it, what it's trying to check. These are broken into CAD, geometry, and PMI checks. And you can decide that, you know what, I want to always run all of them, or some of them if you want, whatever. So in this case, let's run it. So you will decide, is it an ASME or ISO? You want to follow ASME or ISO standards. And it's going to go and start analyzing all your, actually the model, the geometry, the CAD design practices, the PMI, everything that existed there. And it will go through every single combination state and start analyzing it. And you're going to see it start flipping. And it's, you know, for example, it's going to analyze the visibility of every one of those. Does it see anything that can be viewed? So it's flipping the different combination state to figure them out. And one by one, it goes through them. And then it gives you a report. So that report basically is finding all your failed rules. So for example, in this case, we have an overridden dimension. So it's telling you why, what's the rule, why it failed it. And also right on the fly, you can highlight which one it's talking about. So what's the issue? Which one is it that you're talking about? So you can go fix it. Or the other stuff it can do, like here's another one where it's found the single CAD surface should only have one outline, right? So it's failed that one. And some of these rules, like you see here, can be corrected automatically. So here are the identified issue. So there are surfaces that have multiple outline posing problems. So that's not allowed. And basically, you can automatically, in this case, hit correct, and it's going to fix it. Okay. So that's in a nutshell, MBD checker. The point of it is to ensure, and what you can do with all these rules at the end is export them into an Excel spreadsheet. Maybe you attach them to your WT part. You can do with it whatever. So it doesn't have to work always in here. You can have a report about what you've done, what's fixed, what's failing, what's not able to fix, etc. So the point here is to ensure before it goes out, it's fully validated. It has no issues. And there are hundreds, and we probably come up, well, we still have plans for even more checks, but those are, will continue to actually grow. Okay, so once now we are sure that we can have always a properly consistent validated model when we export, we have to bring people up to speed in MBD. And as I said before, we want to bring them to MBD from drawing, the users. But what we want to do is ensure that we don't lose throughput during that transition period. So how are we going to do that? So our idea of moving them is not to move them wholesale, but to move them slowly. Maybe over a 2-year period, maybe over a 3-year period. It does not matter, but moving them in a way without losing throughput. So how can we do that? We have a tool that can take basically a 3D annotated model and make automatically a drawing out of it. And then the idea becomes that, okay, you probably can move 80%, you know how to do maybe 80% in the beginning of your drawing. You can document it in 3D, but your trouble is going to be you have a bunch of table, you have a bunch of notes that exist on this drawing that you haven't figured out what you want to do in 3D for them. So the idea then is that you document everything in combination states, and 80% of the stuff in the beginning will be there. Next year, by you're at 90%, you're at 95, you're at 99, and you get to a point where the move is a very easy move. Everybody's comfortable doing all the documentation in MBD in combination states. And the drawing at the same time is happening automatically. So you're not losing the drawing, and you're able to go and add stuff to it, enrich the other 5% that is still missing until you no longer need the drawing. So that's the idea of how we will transition people from 2D to MBD without losing throughput. So here is basically the product. So I have this this part that is fully annotated with a bunch of combination states in there. And I want to create drawing automatically. So I have some configuration that we can go through here. I can define what I'm, ANSI ISO, whether I want, what kind of, what the sheet's going to look like. And it's going to automatically look at the combination state and start creating the sheets and the views that show that is able to represent what we're seeing in this combination, in these combination state into this drawing. And then after that, the idea becomes, even if it is 90%, you go to the drawing and you keep adding the rest of the information that you might need in here. And if you go and change that drawing, you add stuff to it, you modify stuff from it, etc., and that's affecting, maybe now it needs new views in one of those sheets in order to represent this dimension. Like in here, you see, we did not have a side view on that original sheet. Everything was top view. So it only created a top view in that sheet. But when you go back to it, it's just now able to add the view, add the annotation in the new view, etc. And even you can maybe change your mind on the configuration of that drawing, the way it has to happen based on whatever criteria you decided that you want to do in here. So the idea is that the drawing become automatically generated from the combination views, and then you add to them anything else that you want to enrich them with, because you still haven't figured out how to do it in 3D. Okay, so that's 3D to drawing. And then there's a bunch of other tools to even help with the actual mechanics of the day-to-day work in MBD. So such as annotation, such as creating 2D drawings from stuff, tracking and marking, color coding, etc. So we have a bunch of other stuff, or combination state is another one. But I want to start by talking about context and attribute management, because that's a little bit kind of covers it reflects on everything else, right? So what we want to do is, so we can have rules to kind of define colors, set update rules for updating the parts, rules for adding annotation, rules for exporting to different template and parameter lists, etc. So you have a specific thing, but some of those might be different, whether you have a sheet metal part versus versus a machine part versus a plastic part, whatever, right? So you might have a different set of how you want your MBD documentation to look for these different type of parts, or maybe different department in your company, or maybe different product area that have something special that you have to do with it. So you can dice it and slice the rule set into different context, and you can manage the context and assign that context on its own in this context and attribute management. So this one doesn't really generate anything, allow you to manage the context of the different things that you're trying to do. And from here, now there's a bunch of other stuff you're trying to do that you see these contexts are going to come handy, where you're biasing them based on the type of parts or the different department or whatever. So I'm going to start with update. So update is to ensure that your parts are always up to that you're working on are always up to the latest standard. Now, usually what people will do is you'll have start parts. And with start parts, you start a new model, you're going to have everything that comes from the start part with combination state and layer rules, etc. However, not everything you do start from scratch. As a matter of fact, the majority of what people do are revving up something old that they have. And standard evolve over the year. So what we want to do is always ensure that anything we're working on here right now is always up to the latest standard. So we have this update, which ensure the consistency by always checking models and updating it to the latest standard that we have in there. So, so I'm going to show it here. So it's this check and update. And based on the context of what we have, it's looking and saying, listen, this is a machine part. This one's got something missing in it. Why don't you go and fix it? There is maybe standard parameter that has to be there. There are layers. There are combination state that gets added in here at the bottom. And it just goes and pretty much look at the latest standard, update whatever model you have to that latest standard. You can always start working and always be in that latest standard that you're working with. Very simple idea. It's pretty complex work, but it's really a simple idea to say, as my standard evolve, whatever part I'm working with here will always be at the latest standard. Additionally, what we want to do is help people with these annotations, in placing these annotation, using standard contextual annotation and symbol and placing them seamlessly, making sure that everything comes from a library, but that library is based on the context of what we have here. What part, what department, whatever different slicing and dicing we want to do in our context management. And supporting international and multilingual environment, and basically an easy way to put them in. So I'm going to start it here, and you're going to see. So first, it discovered that this part, we don't know what the context is. So we're going to go and enter the context of what that part is. So it's going to manage now some metadata that maybe it has to happen in here. So if we have a part that doesn't understand its context, we ask them to go and enter the context, and it drives what extra information needed in there. And then we have a bunch of standard annotations that need to go into different blocks of different combination views, and automatically we can decide and automatically start placing these things. So here's the other combination, the standard combination state, and there is a bunch of standard annotation that has to happen in there, and it goes, and you can define any variable that you're allowed to change in them, and it goes and add these standard annotations. Additionally, so we're going to do, there are also notes and stack notes. So let's add some of these notes in here. So here's some notes that we're going to add, and this notes require it to be a reference into something. So you can automatically basically pick and place, change the values, apply it. So a quick way to apply these annotations. Here's some stack notes. So the stack notes are optional thing. You can pick and add, select and add, and it basically will automatically go where it's supposed to go. In this case, it's defined to go on a special combination state. And symbols. So also standard symbols, managing these standard symbols. And I went a little bit too fast. I hadn't got into symbols yet. It's still massaging and changing and editing these stack notes. And in here, we're going to go to symbols and pick on different symbols and basically apply them. So the idea is to make it easy and to apply these annotations, but also to follow certain rules set based on context of what that part is. Okay. Okay, so all right, so going back, let's look. Another thing that also is context specific is color coding. So certain designs, certain business areas, we can use colors to clearly highlight PMI, facilitate how to transfer information to downstream. So the color then would represent different info to be processed. It could be surface finish, it could be tolerancing, it could be anything. So the ability to easily kind of either by rule or by manually deciding and selecting to define the different color scheme and to build these color legend kind of automatically. So here, for example, we're going to go, let's say we have some rules for machined part where it's going to analyze the surfaces, the whole surfaces, and create so automatically to assign and create for threaded or non-threaded surfaces, or maybe board surfaces, whatever, to automatically basically define those. Another one could be that, you know, for tolerancing, to look at the surfaces and define them with either tolerance information and surface finish. And everything that's defined into these surfaces and colors are basically parameter driven. So there's a surface parameter inside them, and this surface parameter gets exported with in the step file for downstream consumption in, you know, for other system basically to consume that information. So just as straightforward as we're talking about here, and also that is also very context specific. So now the other stuff that we see that we want to start consuming that data is maybe stuff that are related to marking, like, you know, first article inspection. So how do we do that one in the context of MBD? So we also created that tool that allow us to mark PMI for first article inspection. But also what it does, it allow us to track any additions, deletions, or revision to all the PMIs that exist in MBD in this combination state. So that to get like traceability and clarity to what is changing. So what you're going to see here is, so let's look at this idea. So we have this model that is basically has a bunch of marking, you know, in 2D, in drawings, you used to see these things in balloons, right? In first article balloons. So we have it here as this P model. First, it's in there, and we can hide it or show it, or selectively hide some of them, or selectively show some of them at will. So you don't have to have two different versions, one of them that's marked and the other one is not marked. So right in the same model. But additionally, it also knows how it's tracked. So basically, if I go in here, I've seen this one. It's giving me this report of every marked PMI. So you see it, you see what it does, you see its information, you see what it's trying to do. So that's the report. But so let's say this is the first version, somebody marked it. Now we're gonna go, and by the way, we can also use it to know what P1 is, where is P2, so it highlights it and zoom to it, and, you know, allow us to find these things. Okay, so now let's say somebody goes here, we have a second version that came in, and somebody had deleted some PMI, added some PMI, modified some PMI, right? So things have changed since the time we did our first article inspection. Stuff changed. So what we have is basically we go in here So we bring the new model version 2, and basically we can tell it, tell me what has changed. So what has changed? So basically what changed is we're going to look and saying, wait a minute, we have a P2, all of those are unchanged, but oh, wait a minute. P11 changed the value. It's a GTOL. The tolerance used to be something, now it's something else. And P22 is a totally new PMI here. And P1 was deleted. So it's even remembering that something before was there, but it's no longer there. And what can we do with that information? We can even extract it to Excel and, do some inspection plan with it, whatever we want to do. So that's the next part that exists in there. Okay, so now we moved everybody to MBD, but still sometime we might need to get, even though we are in MBD, maybe we don't want to create a totally new drawing that is totally new representation, because you're still going to have to put some effort into ensuring that drawing has what you want it in it. What I want to do is put a 2D representation. It could be that you have a supplier that is trying to see what you want from them. Or it could be that you're trying legal. There is some legal requirement where you're signing on something and you need a representation of what that design is. So we have this ability to do 2D PDF export and basically export the multiple combination state into a 2D PDF. It looks like a drawing, but it's really the ISO kind of views or whatever view you have in your combination state. And it follows rules, by the way. You can have different rules. The same when we talk about context, this one also follows the context. It could be that you're doing a totally different package for machined versus plastic part versus sheet metal part, or maybe for different type of supplier, you want to have different type of information that you're sending in there. And what it is, this is pretty much a simple no-brainer, pretty automatic. It's just gonna say, listen, I'm trying to output this. I have certain package that I'm trying to output, go and export it to 2D, put a format around it, around every sheet, and go through every combination view that we want you to go, and here's the output. So the output becomes this 2D PDF. Pretty straightforward. It's useful, but it's not a complex concept for me to address. And now the last thing I want to talk about is, again, even though we fully migrated to MBD, there is no, for years on end, again, you're going to have 2D drawing that you're going to be parts that are made, and the documentation and the master is the 2D drawing. And now you want to rev. So you want to revision to new version because you're trying to do some changes. Again, most people don't start everything from scratch, from start part. That's rare. Actually, that's the most work that engineers do, designers do, is taking something and revving it up. So for years, you're going to have 2D drawing that are the master, and now we're trying to work in 3D. So what we want to do is convert legacy 2D drawing into a 3D combined views. And we want to reuse whatever exists to create this MBD combination. So let's look at it. So that's our 2D to 3D. So basically, I have this model where you notice it has no combination state at all. And I have this drawing that got everything in it. So the drawing is the master. The drawing has everything. So what we want to do, so we have some configuration setting that we can do. But basically what you're seeing here is we're analyzing the drawing for everything that's in it. And out of that, we're going to go and create a baseline combination view for every combination state for everything that we see in that drawing. And we're going to put in it every dimension we're going to see here, we're going to have the equivalent annotation that's going to be in there. And it's not just straightforward, just make the same thing, because you would know that in drawing, most of these dimensions are, are referencing edges, while in MBD, we want to have the semantic referencing the surfaces. So it's analyzing and figuring out, and I'm just going to stop it. It went a little bit too fast here. I should have stopped it. So once that happened, it basically giving me a report about what's able to recover. And in color here, it actually asks a question whether we should color in the drawing what was successful, what has a problem that you have to review in there. And the idea that even if it doesn't recover 100%, if it's recovered 95%, 98%, the job is practically done, as long as you know what you have to concentrate on. And with this report, you're seeing everything that gets recovered, and everything that's not recovered, you have to go deal with it yourself. Still, you're expected to then run MBD checker to ensure that this result is to your liking, not or to your liking, is consistent and is followed standard. So this is kind of in a nutshell what Sigma MBD is. It's a very big tool set. We spent years building and improving, etc. So I'll open it right now for questions. And we still have plans to, by the way, improve the system as well. But I'll open it to questions at the moment.
Okay, we did have a question about the pricing structure, how that's done, and can this be built into our drawing conversion process?
So drawing conversion from 2D to 3D, yes. So I mean, that's the intention of the 2D to 3D tool. The Sigma 2D to 3D is intended to do that. What I would say is that we would never say that this is going to do 100% conversion. It's going to get close. If we target like 95%, because there's going to be things that it couldn't figure out, for example, how to do how to assign the semantics, right? We think for most of the cases, we can take the edge and figure out which is the right semantic to do. But on the other hand, there are certain cases where we might not be able to figure them out. And then a user will have to go and review and add to it. That's why I said you run MBD checker after that conversion in order to see what's acceptable, whether it followed all the standards. And as far as pricing, basically nobody's going to have all of this set. I say, well, somebody might, but you build your bundle on an as needed basis. And I think frankly, I'm not the right person to talk about it. So,
okay, we have another question. What viewer for MBD specifications do most of your customers utilize?
What? Say again, please.
What viewer for MBD specifications do most of your customers utilize? That's from Jerry Schandelmeyer.
Yeah. So I don't have statistics myself, but for all I've seen is Creo view. So. So that's kind of what you would use.
Mm-hmm. Okay. Do we have any other questions? I think someone else is typing. We will be adding new modules as time goes on.
Yes.
So this is definitely something that it's not static. In fact, I had to redo the graphic 3 times already because we keep adding new modules.
Yes. Yes.
Let's see.
So we have a lot of ideas, right?
Mm-hmm.
Whether these ideas make sense is, they have to get to a certain to a certain mass and acceptability, and we're convinced that they have usage in a broad set of, a broad customer base, right? Before we would add them. So we have a bunch of ideas that really we're not convinced that they have broad appeal, so they never made it into this set, right? This is the set that we think they have broad appeal, and that's why they ended up there. I am pretty sure that we are not stopping to think about the problem. As we continue talking to customers, working in this field, I'm sure there's going to be other ideas that come in. Certainly, for example, with the products themselves, they will also keep evolving. Like MBD checker have hundreds of checks, and there are even well over 100 that we want to do that we already in our to-do list, basically. But every time you talk to somebody, you're going to discover something that is a good idea.
Yeah, and if anybody has any feedback or something that they would like to be able to do, please let us know. Okay, we have a question. Are you aware of any way in which Creo can leverage MBD annotations in manufacturing?
Yes. So yes. So it's actually quite an interesting idea, because this is one of our, it's very funny that came in after the question about new modules, because this is a module that we are thinking about. So for example, if you when I mentioned the color, MBD color, so color coding, basically in the surface we have parameters that tell us what we need to machine, or what we need to inspect, or what surface finish we're trying to get to. And the idea that we haven't executed on is that knowing what every surface tolerance and surface finish requirement, etc., would allow us to automatically machine a part. Now, that's a future thinking. It's not something we have right now, but that's the thought. I'm not aware about who does these. Whether certainly in Creo, I'm not so sure. And if we are to address this in the future, it will be in Creo NC.
Okay. Do we have any other questions?
So here's the question, and let's say, so does the 2D to 3D conversion work for any file type, or is it limited? No, it's from Creo drawing to Creo model and assembly. So it's a Creo, so it's not like a PDF or anything like that, right? So what we are doing is taking the Creo drawing. So taking the Creo drawing and reading all its dimension notes, etc., and moving them to the to different combination states.
Okay, well, thank you very much, everybody. Again, please reach out. We'd love to talk to you in more detail about your specific situation and how Sigma MBD could help you. Thank you very much, and have a great rest of your afternoon.
Yes.